Hi, hello, namaste. Previous video, some introduction of coordinate geometry, about geometrical figures, and what is geometry, what is the use of geometry. We are completed. And we know the some of the shapes, how to derive distance. Now, today, how to derive distance formula. In coordinate geometry, how to derive section form, distance formula, derive distance formula. Here we need to find a distance of town A and town B. So we need to find distance of town A, town B. We must be know coordinates of A and coordinates of B. Means here it is. Suppose I'm plotting these town A and town B in the coordinate plane. Suppose it is a coordinate plane. It is x-axis, it is a fixed, and it is also called abscissa, and it is called y-axis. Okay, so we want to know the distance between AB. So first of all, we know the coordinates of A and coordinates of B. Like I'm taking here coordinates of A is x1 comma y1, and here we go x2 comma y2. So for this, our imagination I'm drawing here one of the line which is perpendicular to x-axis, which is perpendicular to x-axis. I noted this as any of the letter P. In the same way, I'm joining here one of the line which is perpendicular to x-axis, that is nothing but Q. Finally, and again I'm drawing one of the one of the line which is perpendicular to BQ, which is perpendicular to BQ. So it is noted as a C. So here we go. ABC is a one of the triangle. We want to know the AC distance. How do we know the AC distance? Suppose it is a origin. We want to know the AC distance. AC is equal to, AC is parallel to PQ. So when AC is parallel to PQ, we want to know the PQ distance. PQ distance is, when you know PQ distance, it is equal to AC distance. So that is equal to PQ. How to find PQ? For suppose here to here is x1 and here to here is x2. I am subtracting in x2, subtracting x1 from x2. So when we remove this, we get this answer. Okay, so that is why here PQ is equal to OQ minus OP. OQ distance is x2 minus OP distance is x1. Similarly, I am taking here BC distance. But suppose BC distance, it is a y-axis. It is x-axis and it is y-axis. Here to here we go y1, and here total distance is total distance. So I am drawing here, we go like this, y2. Here to here distance is y2, and here to here is y1. So here we go. We want to know the BC distance. BC distance, how do we know BC distance? BC is equal to, so here total distance is BQ minus AB. AB distance, because AB is parallel to CQ, that is equal to BQ minus AB means CQ. That is equal to total BQ distance is Y2 minus, and AB distance is Y1. AB is nothing but CQ. Okay, now I'm finding AC BC value. Now coming to the triangle. So from triangle ABC, right angle at C. It is a right angle at C. When it is a right angle at C, according to Pythagoras theorem, according to Pythagoras theorem. So according to Pythagoras theorem, he said that hypotenuse square is equal to opposite square plus adjacent square. Hypotenuse square is equal to opposite square plus adjacent square. So what is hypotenuse? What is opposite? What is adjacent? You want to know the hypotenuse means which is exactly opposite to the right angle. Which is exactly opposite to the right angle. It is called a hypotenuse. And the height of the triangle is called opposite height. And base is called adjacent. So here we go. Hypotenuse means AB square is equal to BC square and plus AC square. You interchange also not a problem. AB square is equal to AC square plus BC square because we want x coordinates at first. Now here we go. AB square is equal to AC square. What is AC? Here we are finding AC value x2 minus x1. x2 minus x1. But AC square, AC value x2 minus x1, but AC square value is x2 minus x1 whole square plus, here it is a plus, BC square. BC means y2 minus y1. y2 minus y1. Here BC square means 4 square. Now we want to know the distance of AB. AB is equal to, the square goes to square root. Now square root of x2 minus x1 whole square plus y2 minus y1 whole square. This is known as distance formula. This distance formula can also be written as AB is equal to square root of x1 minus x2 whole square because x2 minus x1 or x1 minus x2 plus y1 minus y2 whole square, which is also same. So by using this distance formula, we are solving many problems in exercise 7.1.